Hey there, guys. Welcome back to the channel. I'm your buddy Shaunak, and today we are about to dive deep into the fascinating phenomenon of hallucinations in generative AI. What exactly are these hallucinations, and how do they manifest into the world of AI? Hallucinations are instances of where AI generates bizarre and surreal outputs, often straying far from reality. Why does this matter to you? Understanding these hallucinations not only sheds light on the inner working of AI, but also raises important questions about the limit of AI and the ethical implications of AI generated content. How can we leverage AI's capabilities while mitigating these sort of risks of unintended consequences? So let's start.
So let's discuss first of all what a hallucination is, and then we'll discuss why they happen, and then we'll take some steps to describe how you minimize hallucination with LLMs. So, hallucination one on one. What exactly is hallucination when we are talking about LLMs? Basically, outputs that deviate from facts or contextual logic. And basically, when you ask your language model uh, to generate some text, and instead of giving you the facts, it is talking like a fantasy novel on overdrive. Okay, so now we can categorize hallucination across different levels of granularity. So let's say the first level is basically sentence contradiction. What exactly sentence contradiction is? This is really the simplest type. This is where an LLM generates a sentence that contradicts one of the previous sentences. So let's say LLM responded with saying sky is blue today, and then just said that sky is green today. So this is how sentence contradiction operates. So next on the list we have got prompt contradiction. So this is where the generated sentence contradicts with the prompt that was used to generate it. So you give your LLM a simple task like writing a good restaurant review. And what does it do? It returns by saying the food was terrible and the service was rude. So that would be in direct contradiction of what I asked exactly. So next we have nonsensical, sorry, no, next we have factual contradiction. Factual contradiction is imagine asking your LLM for capital of India, and it started saying factual errors like capital of India is Bharat, not New Delhi. Okay, and finally we have nonsensical contradictions where it just puts in something that really has no place being there. So let's say the prompt is what is the capital of France, and the chat GPT is responding by saying capital of France is Paris. Paris is also the name of a famous singer. So which generally has no, which doesn't make sense in this context, right? Okay. So basically, now you are probably wondering why do these hallucination happen in the first place? And that's actually not that easy one to answer because the inner working of LLMs is something of a black box even to the engineers of LLM themselves. They are, but you can figure out like the number of common causes that leads to this sort of hallucination. So let's take a look at few of these. One of these is data quality. So LLMs, as you know, are trained on huge corpora of data, text that may contain noise, that may contain error, biases, or even inconsistencies. Look, for example, some of the training data was created by scraping all of Wikipedia, Reddit, blogs, etc. And we are we are aware that not everything is accurate on Reddit, right? So look, even if it was, even if let's say we assume that training data was entirely reliable, the data may not cover all the possible topics or domains. So basically, LLM tries to generalize from the limited data set that without being able to verify its accuracy or relevance. So that's sometimes it just gets it right, sometimes it just get plain wrong. Okay. So for another reason why hallucination can happen is based upon the generation method. Okay. LLMs use various methods, objectives to generate text. So something called beam search, sampling, maximum likelihood of estimation, or even reinforcement learning. So each of these methods, they themselves have their own errors. Each method comes with its own sets of biases and trade-offs. For example, it takes trade-offs between things like fluency and diversity, between coherence and creativity, and between accuracy and novelty. Next, another common cause for hallucination is the input context itself. The best part about this is something actually we can control as users. It's like giving your GPS directions to the nearest Italian restaurants instead of just saying, take me somewhere cool. So, context is like the GPS of our language models. It's the crucial info we feed them before hitting that generate button. Okay. So, picture this. You ask your LLM buddy, can cats speak English? Seems like a pretty straightforward question, right? But wait, without the right context, our language model might just get lost. For instance, imagine we are talking about Garfield, that cat from comics. In that case, we would expect our LLMs to wild up some answer like, yes, cats can speak English in the context of Garfield comics. Okay? Which brings us nicely to the third and final part. What exactly can we do to minimize these hallucinations? So, yeah, one thing that we can do is provide clear, specific prompts. The clearer the direction, the less likely you will end up in the world of confusion. So, for example, instead of tossing out a very vague questions like what happened in World War II, which could lead to all sorts of tangents, we should get specific. Like, can you summarize the major events of World War II, including the key players and the primary cause? Okay, now that's what I call a clear and specific prompt. Next is we can also employ something called active mitigation strategies. These strategies work on some of the settings of the LLM itself, such as settings that control the parameters of how the LLM works during generation. One good example is that temperature parameter, which controls the randomness of the output. So a lower temperature will produce a more conservative and more focused response, and a higher temperature will generate more diverse and more creative ones. Okay, so basically we can play around with the temperature parameter. So obviously, the higher the temperature, the more opportunity for hallucination. Next, and the final one is multi-shot prompting. In contrast to single shot prompting, where we just give only one prompt, multi shot prompting actually provides them with multiple examples of the output format or the context we are going after. And that essentially primes the model because we help it recognize the pattern, the context more effectively. This can be particularly effective when we are coding, writing poetry, or even asking for directions in a specific style. Because multi-shot prompting, it helps LLM recognize the pattern, recognize the style, and deliver the response with confidence.
So now we know large language models may sometimes hallucinate and take us on a very unexpected journey, but we also understand its causes and we know the strategies to minimize these causes. Then only we can truly harness the potentials of these models and reduce the downsides. As we wrap up, let's remember to explore AI more responsibly and considering both its pros and cons. Thank you for joining me today. If you found this video helpful, like, don't forget to like, subscribe, and hit that bell icon for notifications on future content. And as always, keep coding, keep innovating, and keep pushing the boundaries of what's possible in the world of tech today. Until next time, it's Shanak signing off.